For the next part of the tutorial, I'm going to be talking about data cleaning specifically for an NLP project. Again, you can find all my code on GitHub at a dash of data. In my last video, I talked about the data science workflow, and here are the 5 steps of that workflow. For a natural language processing project, the overall steps are the same, except step 2 here is a little bit different in that instead of using numerical data for data analysis like we're typically used to, now we're going to be using text data for the analysis. And over the next few videos, I'm going to be following this format. So I'm going to show you a presentation, and then I'll be walking through a Jupyter notebook. All right, so the start of any data science project is a question. And the question that we're going to be focusing on today deals with this woman here. So this is Ali Wong, and she is a stand-up comedian. A couple years ago, when I was pregnant with my first son, I was trying to figure out things to watch on Netflix, and I stumbled upon her special, and I really liked it. And that was unusual for me because I'm typically not a fan of stand-up comedians. And so my question was, what makes Ali Wong's comedy routine stand out? Why do I like her routine and not other comedians? And this is the question that we're going to be focusing on today for our NLP project. Okay, so now that we have this question, the next step is we got to get the data. And so for this data step of the data science workflow, there's an input and an output. The input is our question. So the question again is, how is Ali Wong different? And the output of this step should be data that's clean and organized and in a standard format that we can use for further steps. So this is what typical text data looks like in a standard format. Here you see Ali Wong along with other famous comedians, and then the transcripts for their comedy routines. Okay, so there's a gathering and a cleaning piece. And we're going to start with data gathering. So my first question is, okay, now that we have this question, where are we going to get the data? And then how much data should we get? Which comedian should we get this for? For what time range? This is a really open-ended question, and it's hard to narrow down your scope. At the end of the day, after a lot of conflicted thinking, I decided to go with data from a website called Scraps from the Loft, which has transcripts for a bunch of stand-up comedy routines. And then I also used IMDb data to filter down the data, so to specify which comedians I should look at. And this step is a very difficult step in the data science project. It's where we have to define the scope based on your domain expertise. And so there's no right or wrong answer to this step. It's all about what you think makes the most sense, and as long as you can prove that that makes the most sense, then you've got it right. And so at the end of the day, this is how I decided to limit my scope. I looked at comedy specials from the past 5 years, ones that had at least a 7.5 rating with over 2,000 votes on IMDb. So that meant it's a good comedy special and it's a popular one. And then if a comedian had multiple specials, I just kept the one with the highest rating to make my life easier. So at the end of the day, I ended up with these 12 comedy routines. And if you take a look at them, you can see that they make sense. These are some popular stand-up comedians. And then the way that I actually got this data is I scraped this data from Scraps from the Loft. And I used a couple different Python libraries to do this. First, I used the request library. And the formal definition of what it does is it makes HTTP requests. But the simple way to think about it is what request does is it finds a website online and it's able to pull information from that website. So that's what request did for me. Then I use Beautiful Soup. And what Beautiful Soup does is it takes all the content of a web page and it's able to extract certain parts from that web page. So let's say I just want the title or I just want a certain image. I can get that with Beautiful Soup. And then finally, I once I got all this data, I pickled it. So pickling is basically taking an object in Python and then saving it for later. And I'm going to walk through all of this in a Jupyter notebook at the end of this section as well. Okay, so that was my data gathering piece. I was able to scrape all that data. The next thing I did was I had to take all that scraped data and clean it in some way. So the goal of this step is to get the data in a clean, standard format for further analysis. And different types of analysis actually require the data to be in different formats. So I put all the data in two different formats. One is just a corpus, which I'll talk about in a bit, and then another is the document term matrix. Okay, so first let's talk about this corpus. So a corpus is a fancy name for a collection of texts. And this is what it looks like. So I have a comedian, Ali Wong, and then transcript all in its raw format there. And so this here is my corpus. And the way I got my data into this corpus format is I used Pandas, which is a Python library for data analysis, and I put all of this transcript data into a data frame, which is essentially a table within Pandas. All right, so that was the first format, which is a corpus. It's pretty straightforward. All you have to do is you take all of your transcript data and you put it into a table, or I put it into a data frame. This next format is a little bit more complex. It's called a document term matrix. And to create this document term matrix, you need to follow these three steps. The first thing you do is you need to clean the text. So I'm going to go over some popular data cleaning techniques. The next thing you need to do is tokenize the text. So break down that huge transcript text into smaller pieces. And then finally, you can put it all into a matrix so that a computer can process it. Okay, so here is a line from John Mulaney's special, All Right, Petunia. Okay, so it looks pretty straightforward to a human, but if you were to give this to a computer, the computer would have a hard time reading it. So what we need to do is take this raw text and put it into that document term matrix format. Okay, so the first thing we're going to do is we're going to clean this data. And there are so many ways that you can clean data, but whenever I'm working with text data, I always start with a couple. The first thing I do is I remove punctuation. I always lowercase all my letters, and then I remove numbers as well. So there are many other things you can do at this point, but it's good to just start with something simple and see if you're going to be able to get interesting results from it. Okay, so if I do that, then my text looks like this. So it's already starting to look a little bit simpler for the computer to read. And the way I do this is within Python, I'm going to use a library for regular expressions. So a regular expression is, think of it as a really powerful control find. So you know when you're working with some document in Excel or Microsoft Word and you're trying to find a word and you do Control F and then you can find a certain word. Well, with regular expressions, what you can do is instead of finding a word, you can actually find a pattern. So any word that starts with a capital letter or any word that's this many characters, things like that. So it's just a really powerful find technique. And we're going to use regular expressions to do some data cleaning. Okay, so now that you have the data cleaned, the next thing to do is you have to tokenize the data. And what tokenization means is splitting your text into smaller pieces, and each piece is then called a token. So the most popular way to tokenize something is to tokenize it into words, but you can also tokenize it into things like sentences that are a little bit lengthier. But again, the most popular thing is words. So that's what we're going to do here. We've taken all the words from the data cleaning step and we've tokenized them into these individual tokens here. And now that every word is on its own, we can do some filtering. So what we can do here is filter out words that have little meaning. So these are called stop words. So think of things like a or the or on. Those don't have that much meaning, and we can get rid of those for now. So if we do that, then we end up with just a few words. And so at this point, we've tokenized our text and removed stop words. So right here, this is called a bag of words model. And what that means is it's a really simplified way of looking at your text data. And it's just throwing all these words into a bag where order doesn't matter. Even though it's such a simple way to represent your text, it is really powerful as a first round of analysis when you're doing NLP. Okay, so now that we've tokenized our text, what we're going to do is we're going to put it all into a matrix. And the reason we need to put it all into a matrix is because right now in this Petunia example, I'm only showing you one line of text, but we have text for a bunch of different comedians, so we need to put it into a matrix so that the computer can process the information for each comedian. So that final matrix would look something like this. So you can see on the left, we have, in every row, we have a different comedian, and then every column is a different word. And you can see John Mulaney, he says, "Right, Petunia, wish me luck." And then Ali Wong, she says hello a lot and thank you and things like that. And so this right here is called a document term matrix. Each row is a document, each column is a term, and all the values inside are word counts. All right, so this is our second format, the document term matrix. And the way to create this is using two libraries. First, you can use scikit-learn, or actually it's just one library. You can use scikit-learn, which is a Python library for machine learning to create this. There's a specific function called count vectorizer, and what that allows us to do is create a document term matrix. All right, so just to reiterate, the goal of all this was to get all of our data into a clean standard format for further analysis. And we put it into two types of standard formats. The first was a corpus. As you can see here, we're just putting the transcript data into a table. And the second is this document term matrix, where every row is a document, and then every column is a different term. And then all the values are word counts. So the input into this data step was the question, how is Ali Wong different? I was able to gather all the data by scraping data from a website. And then I was able to clean all the data by putting it into a standard format. And now the output of this step is going to be a corpus and a document term matrix. So what I'm going to do now is I'm going to jump into a Jupyter notebook to show you how I actually went through these steps. All right, here's the data cleaning Jupyter notebook. Again, you can find it on GitHub under a dash of data. Okay, so for this data cleaning step, what I recommend is that you go through it in detail yourself. I'm going to go through the high level here, and then hopefully that'll give you a good enough background to then go into everything in detail. So again, for data cleaning, I started with my problem statement. And then the next thing I wanted to do is actually gather the data. And if you remember from the presentation, the way I did this was I scraped some data from a website. And I used a couple libraries. I used requests. I used Beautiful Soup. I'm also using Pickle. And requests and Beautiful Soup allow me to scrape all that data. And Pickle allows me to take all my scraped data and save it for another notebook. So this was a function that I wrote that requests the data from a URL, and then what it does is it soupifies that text. And then in this case, I specifically looked for anything on that website that was of the class post content. And this is specific to the scraps from the Loft website that I was scraping from. I found that all the comedian transcript text was in sections that had a class of post content. And so this is the function I wrote that specifically works for the scraps from the Loft website. And then what I did was I put in all the URLs of the transcripts that I wanted to scrape. And you can see if I uncomment this line right here will actually scrape all of the websites for me and pull out those transcripts. And then at this point, in this step, I've pickled those files for later use. I've commented this out for now because I've already pickled the files. And so after you pickle the files, you can also load them back in to have your Jupyter Notebook work with. And then what I always do now that I've pulled in this data into data, so again, data has all of my transcript data in it. What I'm going to do now is just make sure that my data has been loaded properly. So if I look at data, my data is a dictionary where my keys are all of the comedians and my values are it's all the transcript data. So if I look at data and I look at the keys, you can see I have the 12 comedians right here. And then if I specifically look at Louis and I look at the value for him, you can see here is all the transcript data for one of his comedy routines. Okay, so that was the data gathering step, which was all about scraping the data from a website. Next is the data cleaning step. And for the data cleaning step, this is an iterative process. It takes a really long time to clean text data. And what I typically do is I start by using some common data cleaning techniques, such as making everything lowercase, removing punctuation, and so on. And then I take a look at how my data looks, and then I continue I continue using some other data cleaning techniques from there. So what I'm going to do here is first, I always like to just look at my data again. Again, my key is Louis here. And then if you take a look at my value, it's all the transcript data. Okay, so the first thing I'm going to do is if you looked at this transcript data, the way it was scraped was that instead of having all of the paragraphs or different sections of the comedy routine in one value, it actually gave me a list of text. And so the first thing I'm going to do is I'm just going to combine all that text into one large chunk of text. So that's the step here, combine text. And what I'm doing is I'm taking that entire list and I'm putting it all together. All right, so that is my function to combine all my text. And then this next section, I actually combine it. Okay, so at this point, you can either keep your data in a dictionary format if that's what you're used to, but I really like using pandas, and so I put everything into a pandas data frame. And you can see here that I've taken my dictionary and I've converted it into a data frame. So now we have this really nice data set that has all of the comedians and all of their transcripts. Okay, so let's take a look at the transcript for Ali Wong. So I'm specifically looking where index is equal to Ali, and you can see here is all of her transcript data in one value. All right, so now that we have that, we're ready to apply a first round of text cleaning techniques. Again, this is an iterative process, so I'm going to show you 2 rounds of text cleaning that I did, but you can absolutely do more. So I'm going to import 2 different libraries here. One is regular expressions. Again, regular expressions are used to find patterns in text. And then string, in this case, I'm going to use it to look at a bunch of punctuation marks. So I've created this function, and what it does is It makes all of my text lowercase. It looks at all of these punctuation marks and it replaces them with nothing. It looks at, in this case it looks at all the punctuation marks and it replaces them with nothing. In this case, it's looking for anything that's in those square brackets and replaces them with nothing. And in this case, it's looking at anything that has some digits and is surrounded by either text or digits. Basically, any token that has a numeric value in it or a digit in it, and it's going to replace that with nothing as well. Okay, so this is my first round of cleaning text. And if I apply this to my data frame, then you can see here my text already looks a lot cleaner. Everything is lowercase. I have removed things that have numbers in them. I've removed punctuation and so on. But if you look here, there's still more that I can do. In fact, if you look here specifically, it looks like my string.punctuation list did not include these specific type of quotes. And so what I'm going to do now is apply a second round of cleaning. And in this case, I'm going to specifically put in those other type of quotes. And then I'm also going to get rid of some of these slash ends that were up here. Let's see if I can see any in this sample of text. So you can't see it in this sample of text, but there are these backslash ends that actually came through my text, so I'm going to remove those. And so now I've applied a second round of cleaning to my text. And you can see those special quotes have been removed and those backslash ends have also been removed. So at this point, you can continue to apply text preprocessing techniques or text cleaning techniques, but it could go on pretty much forever. So at one point, you need to stop. And for me, these 2 rounds were a good first pass for me, so I'm going to keep moving on with my analysis. Okay, so I've done some data gathering, some data cleaning, and now I'm going to organize the data. So I'm going to put it into the 2 formats that I mentioned earlier. First is a corpus, so just a collection of text, and then second is that document term matrix. So the corpus is actually something we've already created. So if you look at that data frame from earlier, this is the corpus. I have every single comedian along with their transcript. And then what I'm going to do here is just add another column that contains their full names. So I can use that for some of my visualizations later on. Okay, and at the end of this step, I'm going to pickle it, or basically save this object for later use. Okay, the second format I'm going to create is called this document term matrix. And what's going to happen here is I'm going to use this count vectorizer. And what count vectorizer does is I can call count vectorizer and I can input in my transcript data, tell it what stop words I want. Remember, stop words are words that don't have much meaning that I want to get rid of. And then after I transform my transcript data into this count vectorizer form, I can put it into a data frame and it looks something like this. Again, every row here is a different comedian, or in the document term matrix context, every row is a different document. And then every column here is a different word or a different term. And then certain terms have already been excluded, which are the stop words like the or a and so on. And so now my text is in this document term matrix format. And what I'm going to do here is pickle it for later use. Okay, there's some additional exercises here if you'd like to try them. But again, this whole section was on data cleaning and how to clean text data. My next video is going to be on exploratory data analysis.